everyone, my name is Ahmed Attar. We have talking about a presentation about crash course. Here are my teammates are Hamad, Muhammad Surah, Ahmed Attar, and San. Here's the introduction that I'm going to talk about. Road crashes are one of the major causes of death in our world. These crashes can be resulted due to accidents, human flashes, and intended actions. We can infer that from either reasons humans' lives have been lost. Consequently, intending anti-road dangers are high importance to decrease the amount of deaths and accidents resulting from these disasters. Taking extreme measures regarding this situation is the purpose behind our project. My group and I will be using Newton basic functions, laws of motions to find a solution.
Model design factors. The material we are going to use in our model is cars, ultrasonic sensor, airbag, and external vehicle protection. We will need two cars that we can use them to experience our project idea, which is how to prevent cars from crashes and collisions. Ultrasonic sensor will help us to detect the distance needed to activate the auto brake. Airbag will help us to reduce the amount of damage that the passenger should take it. External vehicle protection will be built in the roof of the car, which contains a flooded-in vacuum-filled balloon of similar material to existing airbags. In case of unavoidable collision or a roadside object, the balloon floats
as fast as possible.
around the car. Our material can handle impact force of 9053 Newton, so I need 5 seconds of collision time to decrease damage.
First material is ultrasonic sensor. An ultrasonic sensor is an electronic device that measures the distance of a target. Next material is power supply. Power supply is basically a device providing power to electronic equipment. Third word is electrical motor. An electric motor is an electric machine that converts electrical energy into mechanical energy. The material that we're going to be using is acrylic board. An acrylic board is a transparent plastic material with outstanding strength, stiffness, and optical clarity. Next, we have a control board. A control board is a panel at which circuit changes are made. Next, we have a servo motor. A servo motor is a rotary actuator or linear actuator that allows for precise control of angular or linear position, velocity, and acceleration. Final material is extension boards. Extension boards are multiple electrical sockets connected in parallel to each other and encased in a shock-proof box. Finished from the materials, we're going to be talking about the expected results. The model we designed for the protection of the driver and any individual or person inside the vehicle, which is the car or truck, utilizes airbags in front and side of the passenger, as well as a protective seal around the exterior of the vehicle, which means the outside of the vehicle, based on the trail dynamics done by each individual car in terms of speed, force, time, and velocity. We have come to an anonymous expectation with regards to different types of collisions, car crashes with an extended duration of time, as well as an impact force of 4794362.6058 N, and below will result in a minimal collision and damage with our model design. However, factors that impact or influence this expectation would be the high momentum of the collision and an impact force higher than the one mentioned above, that our model might fail in a certain areas in the outside protective seal. We believe that the internal airbags will suffice and are capable of releasing and protecting the individuals in the vehicle at any collision.
Here we have the freehand sketching. This is how our model is going to be. And here what we have is the isometric drawing. This is what it is. Here we have the orthographic views front. Here's the front side of the view when it crashes, but there's an airbag in the middle. Here we have the 3D model. This is where we represent our idea, what we actually make it as a model. We have the graphic view side. Here's the two pictures for example of it. We have the orthographic view top. Here's an example of it, but from the top side. The end. Thank you.
Good morning. So first of all, we added the ultrasonic sensor, which measures the distance and calculates the speed to when to stop. Okay. So then we added the control board, which is used to as a brain for the entire project. And here we have the extension board, which is used for when to add code and to add an extension. So here down here, we added the servo motor, which gets the information from the control board and then gives it to the electric motors so it can stop. And the electric motors are motors that rotates the wheels. And here we have the power supply, which is used to give power to the entire project so it can run. And now I'm going to show you a live play of the project. So as you can see here, the project measured the distance and its speed and stopped exactly 5 centimeters away from the wall.
Ultrasonic sensor. In our program, we have displayed the distance measured by the sensor in inches and centimeter throughout serial port. So first we are reading the temperature and humidity values from the DHT22 sensor, and then use those values to calculate the speed of sound. Then we get the duration the sound wave travel in microseconds, convert them to seconds, and calculate the distance from the sensor to the object in centimeter. So in result you will see the distance measured by sensor in inches and centimeter on Arduino serial monitor. Then the servo motor, which is a small device that has an output shaft. This shaft can be positioned to specific angular position by sending the servo a coded signal. As long as the coded signal exists on the input in the input line, the servo will maintain the angular position of the shaft. If the coded signal changes, the angular position of the shaft changes. So by changing the NOP position, servo motor will change its angle. So when you will when the program starts running, the servo motor will rotate slowly from 0 degrees to 180 degrees, 1 degree at a time. When the motor has rotated 180 degrees, it will begin to rotate in the other direction until it returns to the home position. And the last important thing is we coded the motors. So we just coded the motors to go forward, and it will stop only when the ultrasonic sensor will give a signal or information that something is in front of it, and the distance should be 5 centimeters. So we used the void loop. The program starts directly after the opening curly brackets, runs until it sees the closing curly bracket, and jumps back up to the first line in the loop and starts all over.
The conclusion. To conclude, we can derive our understanding magnitude of impact force is simulated by time. Engineers have developed a method to increase the time of impact and decrease the compulsion experienced by participants of the crash. Since the more time is given at a collision, the safer the humans involved in the crash will be. Thank you.